as a software developer, as well as being on the data analytics team. And then we kind of do a lot of like implementation of web analytics for a couple of enterprise clients in Australia. And then for anyone who wants to contact me, you can basically just contact me at my email, which is really long, that I'm trying to get a shorter one, but yeah. Cool, so yeah, so today's talk will primarily focus just on BigQuery, which is basically similar to AWS's Redshift offering for those who have used that before. The key difference with BigQuery when you compare it to like Redshift though, however, is that it's serverless, which basically means you don't have to worry about any of the configuration of the server, while in Redshift, you sometimes would have to go in and configure the server yourself. You can basically think of it as SQL as a service. So basically the main key concept about it is you would just basically shove some data into it as SQL tables, and then you can just write SQL statements to do an analysis on it. Yeah, I'll provide a demo of it in bit later in the talk. And then on top of that, I'll just also be giving a brief background into like data engineering concepts to get started, just so that we can see how BigQuery would fit into like the overall data lifecycle and whatnot. Yeah, so to get started, so it's basically the first question is, what's a data pipeline? So data pipeline is pretty much what it sounds like. It's just a process of different automated processes where you'd move the raw data from point A to point B, and then you have multiple touch points along that pipeline where you could, do certain operations on the data. So for example, you could transform it, clean it of anything bad, of anything else. For example, you could remove personal identifiable information from data, as well as perform validation before you store it and delete somewhere. So basically, you'd usually capture data from like a web application or app, for example, move it along, do your stuff, and then eventually you'll store it in like a data warehouse where some business intelligence people or data science people can access it and then perform their analysis on it. So the first question they typically ask is, why would you even bother with creating data pipelines? I mean, can't you just use an API and then just throw the data somewhere and then let the data scientist people worry about it? So I found this cool diagram on the internet, which pretty much perfectly describes the relationship between teams and companies that work with data at scale. It's known as the infinite loop of sadness. So the way it typically works is a business person that's high up would reach out to their data science teams with a ridiculous request, to find like a request such as find me how many people did this thing on this day kind of thing. And then the data science people would basically then reach out to the data engineering people to implement something even more ridiculous, like, can we use AI or machine learning and that kind of thing. But then in order to do that, the data engineering people would then reach out to the ops teams and then ask them to scale up. But then obviously the ops team, in order to scale up, they'll have to upgrade their servers and whatnot. And then they'll have to ask the business people for more money. And then business typically don't like spending so much, I guess, on like infrastructure as when compared to like, implementing new features. So they'll push back and then it basically goes the other way. And then, the ops people say, oh, you can't do it. And then data engineering people would tell the data science people, oh, we can't do it because we don't have the infrastructure. And then the business people get nothing. So the key lesson here, I guess, is building data pipelines can get pretty expensive depending on how complex you build them. But in all honesty, data engineering is basically just an enabler for data science people to be able to perform analysis, because before you can actually perform that analysis, you obviously need to capture enough data in a big enough sample for it to be meaningful. Otherwise, there's not much that they can do. And so that's where data engineering really comes into play. It's really about, building data at scale, and then building pipelines which are reliable and then can be trusted upon by other teams to process and then store data ready for analysis. Yeah, so usually typically when we're interacting with big data, so like data on a larger scale, we usually focus on certain dimensions of it. So it's sometimes known as the 4 Vs. Some people call it the 5 Vs, depending if you include value. So basically volume. So that's just talking about like how much data you have. So when data engineers build pipelines, they always have to basically consider like how much data they're trying to process and capture, because that would influence the infrastructure and then like how powerful or how many instances you would have to spin up. Velocity is also another consideration. So velocity refers to like how fast do you need the data to get to you. So for example, some businesses would need like real-time analytics for like if they were doing monitoring on servers, that kind of thing. Or like for example, other businesses might, for example, be able to just if data is available and processed like once a day, that'll be enough. So for example, if they just wanted to process all the transactions for the company each day, then so the requirements would differ depending on how fast you need the data to get to you based on those business requirements. And then the third V is basically variety. So they would also have to consider like what type of formats that the data is coming into the pipeline. So for example, you might have CSV files, you might have PDFs, you might have XML, JSON, that kind of thing. So they really have to work out like what's the incoming data and then how they can be connected together in order to perform analysis. And then the 4V is basically veracity. So that's basically about like how trustworthy and credible the data is, because even if you have a lot of data, if it's not accurate or it's been collected wrongly, then it's not really useful. So in order for it to actually work, when you're collecting that data initially, you have to make sure you actually collecting data that analytics teams can use. And then the last V obviously is just value. So it's also like considering how much value you get out of data. So basically, if you don't have enough data incoming, there's really no point of building like a very complex data pipeline. So it's really just a consideration of like how much the cost of setting up like a whole data pipeline process versus like how much value you would actually get out of the analytics side of things. Yeah, and then this is just basically a blueprint of like a typical data lifecycle. It's not necessarily GCP specific. So for example, other platforms like AWS or Azure, they would have their own tools that can take care of certain parts of this diagram. So the typical data lifecycle is basically you connect to like a app or web application, mobile app, a server, and then you'd use like an API, like a gateway, which basically ingests the raw data, and then it basically comes and passes it through like a message queue where it waits to be processed, or it could even be cached. And then once it's ready to be processed, there's usually 2 typical ways you can send the data into like a data warehouse. So you can usually do like a real-time streaming where you're streaming it in real time. So that's usually useful for tasks such as server monitoring or fraud detection. So that's typically when that would be used. And then on the other side of the fence is you have batch processing, is basically where you collect the data on your initial source, and then over a period of time, and then you send it in one go. So for example, that might be you might process all the transactions a company gets at the end of the day every night. So that's an example of a batch processing. And yeah, so once the data has been collected and processed, they usually stick it into like a data warehouse in like a structure that's ready for a analysis to connect to, and then they would use their BI tools like for example Tableau, that kind of thing, to visualize. And so that's pretty much just start to end life cycle of how you capture the raw data and then eventually how it gets used by data science teams on the other end of the spectrum. Yeah, so now back to BigQuery. So as I mentioned, BigQuery is a GCP platform product. So based on the data lifecycle, it's typically used for like the storage of raw data. So where the data lake. So it can be used as a data lake, or it's also more commonly used as a full enterprise data warehouse. So it's basically a serverless data warehouse, which has been designed specifically to be able to handle large data sets. So think of, like a lot of gigs and a lot of terabytes of data. So it's able to, it's designed specifically for that kind of size of data. And then, so basically the key concept is you would import any data as SQL tables into BigQuery. And then you can pretty much just write SQL statements on the fly to perform, manipulations, analysis on that data set. And then BigQuery uses just like, normal SQL, so NZ SQL. So it's actually quite easy to get started with. And then it obviously has like a web console, which you can use to do stuff manually. But then it also has a REST API, which you can interact with so that, you can stream data into BigQuery using like, Python or Java, as well as, ways to automate it. Yeah, so with BigQuery, you basically have to pay for both the storage and processing of the data. So there's two ways you can pay for it. There's an on-demand, which is, you pay for how much you actually use. And then the other option is you can also do like a flat rate. But then the flat rate option is typically used for large enterprise clients who store a lot and then, process a lot of data. And then I think it's about $5 per terabyte when you write SQL statements. So for every terabyte, you pay $5. And then storage would then also of the data depends on how long you store the data for. So typically it's $5 for 500 gigs if you store it for half a month, which basically means, $20 if you do 1 terabyte. But then the thing with this payment of when you're paying for the storage of data is if you store the data for long enough, so if it's been there for more than 90 days without being edited, then they basically halve that storage price in half. So then it goes down to about $10 for a terabyte per month. And then just with the data, how it's stored in BigQuery. So basically you have your BigQuery service, and then you obviously create like a project, for example, which is your overarching to hold everything. And then you basically can create multiple data sets, which is basically a collection of different tables. And then the tables itself is what you would import into BigQuery. One thing about BigQuery though is that it really likes denormalized tables. So, big fat wide tables, with nested and repeated data. You don't necessarily have to denormalize your tables before you import them into BigQuery. It just performs better if they're denormalized. And then plus since the storage is cheap, it doesn't really matter if you have repeated data in records and whatnot. And then I'll just talk about ETL quickly. So ETL is a common process used in data engineering to basically extract some raw data and then store it somewhere. It stands for extract, transform, and load. It's a traditional way how older on-premise data warehouses would be used, but it's also applicable to cloud data warehouses just because the cloud platform processing is so good these days. And then the way it works is basically you ingest your raw data on the far left, and then you push that raw data to a staging area, which is where it just sits there. So it can act as like a backup copy, I guess, as well, in case you need to perform additional or you have errors in your pipeline. And then you basically have a process which transforms and then loads that raw data into a structure. So like it goes from raw data into structured data, and then you basically load it into a data warehouse where it's ready for a data science team to pick up and then retransform and then visualize So that's like a typical process that's used. And then when we apply it to the GCP, so you obviously have your raw data coming in from all your different sources. And then what we can do is we can use Google Cloud Storage, which is basically Google's equivalent of AWS S3, to just keep all the raw data there. And then you can basically have a process here somewhere using like data flow, which is similar to AWS data pipelines, which then manipulates and transforms that raw data and then sticks it into BigQuery. And then the cool thing about BigQuery though is you don't necessarily have to use cloud storage. You could, for example, stick the raw data into staging tables in BigQuery directly, and then manipulate them in BigQuery and then produce your, structured, tables. Oh, and I think, so that's enough of me talking. So I might just give a quick demo of what BigQuery actually looks like. Can everyone just confirm they can see my new tab?
Yeah, it's good.
Yeah, all good. Yeah, cool. Yeah, so this is the GCP UI for BigQuery. It's the newer one. And then, so you basically have, all your, on the left here, you would have all your data sets and tables. So this is your project. So in this case, it's BigQuery public data, which is your overarching project. And then you'll have basically all your different data sets here. And then under each data set, you would then have different tables, which is where you put the data into. And then on the right here is basically your query window, which is where you write all your SQL statements to query against these tables, and you can perform joins and whatnot. And then you also have a preview bar here, which gives you the schema of the different tables, and then some details about it. So this particular example here is for Hacker News. So basically there's a publicly available data set which stores all the different comments for Hacker News. So for example, this particular comments table has, 8 million rows, which is not too big, I guess, in BigQuery. So it's about 3 gigs of data. Yeah, so basically you can just write SQL statements here. Then it will tell you roughly how many gigs will be processed. One thing about BigQuery is you don't want to do a select star, for example, because you're charged basically for how much you process. And then if you do like a select star, it basically does a full table scan regardless. So it's one of the things to keep in mind. And then also another thing is limit doesn't do anything. So for example, if I did limit 100 here, it would still do a full table scan if you use star, so it doesn't do much. So you want to just, query the columns you actually want to get back. And then this particular example I got here, it's basically just looking in the comments for any ones that have the word Python into it. So it's doing a regex match against every single row. So what's that? 8 million rows, I think it was. Yeah, 8 million rows. So if we just process that, so if we run it, yeah, cool. So basically it's done a regex match against all the 8 million rows, and that took what, about 2.9 seconds, which isn't too slow, I guess. And then just to up it up, for example, I got this written down because I don't want to do live coding. So another bigger data set that we have here is for Wikipedia articles. So there's basically a table that keeps track of all the visits to certain pages. So if we do, that's not the right one. That's this one here. That data set, Wikipedia. Cool. 20. Yeah, cool. So this is this particular table basically keeps track of all the different page visits and how many people visited it in 2011, January. And then this one's a bit bigger than that previous table, and it has, I don't know, what's that for? Yeah, Yeah, so that's the number of rows. I don't know what that is. Is that 4 billion? No?
4 billion, yeah.
Yeah, 4 billion. Yeah, looks like 4 billion. Yeah, so that one has 4 billion rows, and it has, and it's a lot bigger. So it has about 246, so almost 250 gigs of data. And then if we run like a sum on every single request, grouped by like what page you're visiting. So grouped by the request. So if you run that.
Are you paying for these queries right now, John?
Yeah, so they give you like a free, they give you 1 terabyte free each month.
Oh, okay.
But I just signed up for a new account so I can use the trial, which gives you 300 UST credits. Yeah, so which should cover this demo, which is good. So I don't have to pay for it. Yeah, so that did what the 4 billion rows. It only took about 10 seconds, which is really quick. And then the cool thing about BigQuery tables is you can also do like a table suffix if you want to, query across, multiple tables that have a similar suffix on it. So for example, in this one here, because in this particular data set, they group all the tables by the month and the year, we can do something similar to like underscore star, and then you can specify the suffix. So we want all the ones that happened in 2011, and then that would do what, 2.3 terabytes. So if you say it's about 250 gigs in each table, times that by 12, so whatever that is. I'll just run that. That's going to take a while. It takes about a minute, I think. So go back to the presentation. Everyone can see my presentation still? Okay, so yeah, so basically, this is just the architecture of how BigQuery works. What I really like about it, I guess, is that it abstracts, your storage from your computing. So you don't see what happens on the storage side of things. You really just have to worry about, writing SQL statements, and you don't have to worry about, if you need to scale your infrastructure or not. It's because BigQuery is basically really highly scalable. It just elastically scales for you in the background when it needs to, when it receives a query. And then, so basically BigQuery is built on top of Dremel in the background, which is basically Google's internal query engine. So Google uses it for services like YouTube, Gmail, search. So it's actually quite fast, and you get access to that power. And then that Dremel engine is basically on a Jupyter network, which moves different nodes, and then that network does like I think 1 petabit per second, which is like really quick. So basically how it works is on the client interface, you'll write your SQL, and then the root nodes would then be responsible for receiving that SQL statement. And then it basically passes it through to these leaf nodes, where it breaks the query into like, separate bits and then does its own things. And then it comes back together, and then these mixers basically aggregates the results and then passes it back to that root node, which then delivers your result. So it's actually quite fun. You don't see any of this, obviously, but it's yeah, quite good, and because it just abstracts it away from you completely, so you don't have to worry about it. One thing about BigQuery though is that it does have its limits sometimes. So for example, if you do too many joins or order by statements, it can fail because the network needs to shuffle everything, and then it just, the query will fail. So if we just now go back to our BigQuery statement, yeah, so for example, this one, so response was too large to return because there's too many rows. So if we just limit that to 100, that should now work. Yeah, because I think the problem is when we use the yide as a limit to how many rows it can show. Yeah. Yeah, I think this one will take about 30 minutes. Oh, sorry, not 30 minutes, 1 minute. Yeah. So we'll just give it a little bit more time. And then one cool thing about BigQuery also is with the results, you can obviously save them or export them into different tables. So you can perform all this manipulation on the cloud directly. You don't have to have another service hooking into it. Should be almost done. Yeah, I tested this last night and I think it took about a minute. Oh, there we go. Yeah, cool. So yeah, so that took about 50 seconds and it did what, 2.3 terabytes, which isn't too bad. Yeah. And so that's pretty much all I wanted to cover today. Was there any questions from anyone or?
Hey, John, is there anything in terms of like nice business reporting tools that can use with BigQuery?
Yeah, so because it's on GCP, it plays best with Google products, unfortunately. So there is a visualization tool called Google Data Studio, which I'm pretty sure it's free now, and it lets you connect to BigQuery. The only thing is, if you're doing like, so there's two options with that. You can either export it as like, static tables, and then just use those static tables in Data Studio, or you can also hook it up as like a actual SQL statement, but then obviously you'll pay for every time you process that SQL statement. Yeah.
Okay, cool, thanks.
Yeah.
Cool. Thanks, John.
Cool. All right.
I think if people have questions and we don't get to them today, we could just reach out in Slack as well in the channel. If that's cool.
Yeah, that's cool. Yeah.
Awesome. Todd, you're here. Todd?
I made it.
You've made it. Great.
And to be honest, it knocked any sort of nerves I had out, because anything that could go wrong did go wrong. So, but I'm back.
Right. Perfect. So I think, correct me if I'm wrong, your one, instead of sharing your screen, right, people just need to pin your video.
Yeah, essentially. So this is a bit experimental, everyone. So yeah, let us know how it goes. But pretty much, as like Jesse said, just I'm just going to be presenting with my camera. So just pin me to the screen, and hopefully we'll be able to see some stuff. Okay, I'm happy to go while my modem holds out. So I did a few test runs on 4G in the 5 minutes before I connected, and it wasn't going to happen. So anyway, I made it. So thank you very much for waiting for me. This is my presentation. So my name's Todd Turner, platform engineer, and I do a lot of infrastructure stuff, which I really enjoy. That's my handle on the Silicon Slack. If you've got any questions or want to know more, I've also got email, LinkedIn, all that sort of good stuff. Now, like I said, this is a new format. So when playing around with this, I made this card. I'm like, oh, that'll be cool. I can put my contact details up there. I realized what an actual waste of time it was for me to do all that, because with this cool software, you can actually like make yourself a rectangle like this. And like, I should have just like done this, because then you actually get a live view of who I am, right? So yeah, that was a bit annoying. But anyway, that was pretty cool. Look, I've aged. That was a bit of a joke. I'll switch back to how I should be. There we go. I'll float over here. Let's get this actually started. So yes, I work at 9. I did a pretty big spiel on all the sort of facets that sort of 9 is in at my last meetup chat. So yeah, we do a lot of stuff. I'm in the digital publishing, sort of more related to that area. So the digital masthead newspapers, so AFR, Sydney Morning Herald, that sort of thing. So my actual talk is on Terraform, and I've labeled it Terraforming the Boring. Can't someone else do it? And this is, I guess, a story about my introduction to Terraform, because I hadn't used it prior to this actual project. And I've seen Terraform previously used for very, I guess, large-scale infrastructure and handling really big stuff. But this is sort of nearly the opposite of that. It was sort of a bit of an experiment to see if Terraform could remove a small annoying thing from our to-do list. So this is the story of that. So it's not a very heavy deep dive into Terraform. So it's not going to be too meaty. Good introduction. But if anyone does have questions or wants me to talk further into the certain aspects that I might touch on, please just call out or let me know, and we'll get there. I did a poll, as you might have seen. So I shouted out to the channel to see actually what was everyone's sort of prior experience with Terraform. Because I actually didn't really know. It's a bit of a mix. So I actually haven't looked at the results yet. Unfortunately, only 6 people have responded, but I'm gonna reveal the results right now. Okay, that's good. So majority of the large, John's going to be laughing at me with my data engineering here because there's really not that many results to go off. But yeah, it does look like we've got a lot in production, so that's probably good. We've probably got a good audience for this chat, so that's cool. So I'm going to start off with very basically, what is Terraform? Now, again, I'm going to be really abusing this software and using it to its full potential. So I'm going to go straight to my web browser here, and this is actually the Terraform website from HashiCorp. And they've got a one-liner here, which really just sums it up. Use infrastructure as code to provision and manage cloud, infrastructure, or service. And that's what it does. It allows you in a declarative manner to define what you need, and it'll go and do it. I'll scroll down here. They've got some nice examples in the wiki that they've got there. All right, here we go. So I'll refer to this diagram a little bit more detail later. But essentially, it's infrastructure as code using a very human readable language. So it uses HCL, it's declarative, and it's very powerful. And not only can it hook up to your major cloud providers, it can manage services with various SaaS providers, yeah, all that sort of stuff. Now, I'm not going to reveal too many secrets, hopefully, by saying at 9, we're a fairly heavy user of AWS services. We do use multiple clouds, but we do a lot in the AWS space. And I'm going to dive in even slightly deeper, which again, hopefully doesn't reveal too many secrets. But we do have a section in our infrastructure where we use this setup. So we've got an EC2 cluster with a load balancer in front of it. And that's served by a CDN being CloudFront. And users connect to that CloudFront distribution in an encrypted fashion, in a secure fashion. And it's encrypted using TLS certificates. Again, this isn't that outstanding. This is a very regular design pattern, and I'm assuming a lot of places use something similar already. Now, ACM, which is the certificate provider, it's like I said, it's a service in AWS. It's pretty neat. You can see there up in the top right-hand corner, it uses Route 53, and that's all part of the validation of your certificates. So you got 2 choices when you validate stuff. You can use email validation, and who doesn't love receiving emails, right? So you can do it that way if you really want. So AWS will send your admin email address a verification email and say, hey, you actually want this, right? And you click yes. That's not super great if you want to get out of your inbox, right? So the other option is to use DNS validation. Now, DNS validation is pretty good as well. So when you make the certificate, AWS will give you a key value pair. It's actually a CNAME record that they want you to put into your DNS zone. And if you do, and they see it there, they're like, well, clearly it's verified. You own that DNS because you've added that record. And that's probably the preferred method, I'd say. Now, that's how we were actually managing ACM. So we were doing DNS verification. And the other cool thing about ACM is it allows you to actually auto renew when the certificates expire. So as we know, you might set a TLS expiry to 12 months, maybe 24 months, depending. And there's got to be a certain criteria met for the auto renewal to happen. Now, in some cases within our team, there was a few little niggly things that made it that this auto renewal was not going to happen. And that's fine for 1 or 2 renewals. However, we manage hundreds of DNS domains with different certificates. So we got one, and yeah, okay, cool. We can just go to the console, just click, and it'll be done in a few seconds. However, just like Charmander up the top right-hand corner there, it felt a little bit like this at times. So no sooner had we actually renewed one, probably a couple of days later, another one would spring up, say, actually, I want renewal as well. And then another, and then another. Again, it was very small, minor job, but it got a bit annoying, especially when you want to do other things, right? So I wanted to come up with a way that we could, for these certificates that weren't eligible for auto renew, was there a way that we could actually do it better in a more automated fashion? I had heard of Terraform at this time, and I just wanted to use it really to see how it would handle this job. And like I mentioned, it's not an overly large job, but it's probably an example of where you could use it on a smaller scale. So going back to our architecture here, I've highlighted in purple sort of what I wanted to terraform, if that makes sense. So I wanted Terraform to control the certificate. I wanted it to control the validation of the certificate, and I wanted it to pass it on to CloudFront as well. I didn't want to touch the ELB or the cluster because, again, that was sort of outside the scope of what I wanted to do. Just that small aspect of it. Again, I do want to jump straight into it as well. So this presentation isn't actually fully focused on the end product. It's more about the proof of concept that I did following this idea. So if you, again, stare really hard at that diagram, I'm going to change it quickly. And this is actually the proof of concept that I came up with. Bam. It's exactly the same architecture, really, except instead of going to an ELB, instead of CloudFront being in front of an ELB or with a cluster behind it, I'm just going to have an S3 bucket. And like Jesse, I dabble in front end every now and then just to pretend I'm a developer. And Gatsby was something I was playing with at the time. So like, hey, I could just get an S3 bucket, throw some static files in it, put CloudFront in front of it, and get Terraform to actually control all that. So this is sort of an overview of that proof of concept, really. So this is that diagram I said that I'll refer back to. And again, I hadn't used Terraform previously, so I actually didn't know much about how it worked or how you use it. So as you see with this diagram, you're a practitioner. It really sounds medical, which is pretty cool. I feel like a doctor of infrastructure. And you're going to put your infrastructure as code in some sort of source control. And then you do this plan apply thing. And I'm going to show you how that works soon. But that's what Terraform does. It plans and applies what you want to do. And it interfaces with the services or the cloud providers that you're interested in. And then it spits out your actual physical infrastructure. So that interface there is, I guess, where providers come in. So very quickly, when you dive into Terraform, you're going to find out about providers. And that's the glue between you and your end infrastructure. And the providers literally just provide like an API pipe between your infrastructure as code and the service you're talking to. But you need more than just providers as well. So again, I'm going to rely heavily on this cool new software where I can jump to my web browser. So let's actually read the documentation. So like mentioned, we use AWS. I'm going to shuffle down here. So this is the AWS provider. This is the actual live document. And you can see here, they show you how to set it up. you put in, your credentials and stuff like that. There's multiple ways that you can authenticate to the provider. And if you think back to my architecture, it's like, okay, well, I need an S3 bucket, right? So you go to S3 on the side here and you drop it down. And there's all the resources there that you can actually define. So you can define an S3 bucket. You can define an object in that S3 bucket. So being the naive Terraform user I was at the time, I clicked on S3 bucket. And it tells you what it does. So this resource will provide you an S3 bucket. Exciting. And they've got, the documentation's very nice. They give you some examples. And to my luck, straight away, I didn't have to think, because straight away, the second example is how you set up a static website. Just essentially nearly copy and paste that word for word. The actual parts of that resource, if you want to know more about what you can do with them or what options they have, again, just keep scrolling and they tell you all about them, if they're required, what they do, any sort of dependencies that they may rely on. So again, it was super simple to use and find out about it. So this is, that's Terraform a website. So I sort of alluded to, we need 3 building blocks to make a static website with Terraform. We need an S3 bucket, our TLS certificate, and CloudFront. So let's start with the S3 bucket. I'm going to bring up the code block for what I actually used. Now I'm going to get it out of the way. That's better. So that was pretty much like you saw a copy paste of what I found on the documentation there. So I've just defined a bucket, made it public, and told S3 where my root object was going to be. And that's it. That's an S3 bucket there in what, less than 20 lines of code. Moving on to the TLS certificate, even better. 3 lines and you get a TLS certificate. Just plug your name in for the website that you want and you're good to go. However, certificates actually aren't quite that straightforward. So remember that Terraform's declarative. So when you say, I want a TLS certificate and I want to associate it with a CloudFront distribution or Elastic Beanstalk or whatever you want, the Terraform provider can't actually do that if the certificate's not ready yet. So it needs some way of actually, I guess, waiting for the creation and also waiting for validation, because it'd be pretty annoying if you made a certificate and for whatever reason it wasn't validated, then you're trying to like associate it with a CloudFront distribution. So certificates have this neat little wait block in, might expand that a bit. They've actually got a nice little wait block, which is the bottom block of code there, that second resource. So what that does is it actually says, okay, when I create my certificate, good, it's done. But now, using that top block, so the top resource there, that's the, remember I said that there was a record to validate DNS that you got to put into your DNS zone? That record it'll insert that record to prove that you own it. And that bottom block, the validation block, will actually sit there and keep polling the certificate and say, are you valid yet? Are you valid yet? Are you valid yet? It'll just keep doing that until AWS finally sees that record in your DNS zone. And then once it's valid, it'll go, oh, cool, it's valid now. I'll move on to the next part of the build process. So again, that was nice. So you don't actually even have to touch the validation. It'll do that for you. Last little bit here, CloudFront. Again, it's pretty self-explanatory here. You can see the origin ID of the CloudFront is, again, referring to the S3 bucket that I made like higher up in the code. So in the HCL, everything references each other. Root object's going to be index.html. So when people actually hit the CloudFront distribution, it'll just show them that. And the whole crux of the presentation is about assigning a certificate. And you can see I've cut out a bit there because it's actually a little bit lengthy. and the viewer certificate. Again, that's referring to the certificate that we made previously. So once it's ready and once it's validated, that's the one I want to use. So going back to our diagram again, so we've made our infrastructure as code, and now we want to actually terraform the thing. So you can see here, we got a plan and we got to apply. So planning is essentially Terraform just doing a dry run on the code. It's going to say, well, this is what you said you want, and this is what I think, this is like what I would need to do to get there. So it's sort of more for the humans sort of watching over Terraform to see that it's doing what we think it's, well, it's going to do what we want it to do essentially. So sometimes you might find some quirks in that. You might change one little parameter in something that's existing and you go to Terraform, plan it, say, hey, I just want to change this one little factor of the infrastructure. And it's like, sure, I'm going to tear it down and make you a brand new one. And it doesn't do that with everything. It depends on what the resource is and what the parameters you're changing. Sometimes there's no way to just do a in-place update. Sometimes it's got to tear something down and create a new one. So you got to watch for those things, because if it's something critical or a load-bearing piece of infrastructure, you might want to do it out of hours or in some other like blue-green fashion. So we're going to do some terraforming, very light on, so don't worry. This is the actual bit of Terraform. I'm going to move over here. Let's bring it up. This is my terminal, and hope everyone can actually see that. Oh no, I failed a calce. Ah, oh well, I'm going to clear that. Embarrassing. Anyway, let's, I'm in the actual directory. So you can see here, that's all my Terraform files. And let's actually do a plan. So it's literally as easy as that. Terraform is now looking at our HCL, and it's now going to actually talk to AWS and say, hey, what do you got? So you can see there, it's refreshing the state of sort of what the resources that I'm going to be referring to. So it's looking at the DNS zone there. And it spits out a plan. Now you can save this plan if you want, or you can just sort of just view it like we are here. So you can see here, it's going to add 6 resources, and it's going to do nothing else. It's not changing anything. It's not destroying anything. And that's good. Me as the operator, I know, yeah, that's cool, because I actually haven't got any of this stood up yet. And again, scrolling a little bit further up, again, Terraform will perform the following actions. It's going to make a certificate. It's going to validate the certificate. It's going to make a CloudFront distribution. And you can see here some of the parameters. It actually doesn't know what they're going to turn out like until it makes the thing. So things like unique IDs. Well, I don't know what it is before you actually make the thing. We'll find out once it's done. But some of the things here, you know, like we've already specified, hey, I want to use DNS for my validation. It'll say, yeah, okay, I know that that's what I got to do. So if we're happy with that, what you do now is do a apply, Terraform apply. Now you can pass in, like I said, with the plan, you can do an output file, and you can literally just pass the apply. You can pass the plan file to the apply. If not, it's going to do, again, similar to our plan, it's just going to do a little mini check to make sure, hey, you sure you want to do this? And you're like, yes, pull the trigger on this thing. Let's get it going. And that's it. So you can see there, it's creating my S3 bucket. It's creating my certificate. And it's completed those 2 things. And now it's going to put the DNS record for my validation into my DNS zone. And it's just going to sit there. It's going to make sure that that record's been put in there properly. And that's essentially it. You can now walk away. The longest part of this process is the CloudFront distribution creation. So in this example here, it is going to create a CloudFront distribution. And similar to the certificate where it waits for it to be valid before it moves on to the next step, with CloudFront, Terraform actually waits for it to distribute globally as well. So that process can take up to 10 minutes even, and it'll just sit there and just keep monitoring it for you. So you can see there the record was inserted into our DNS zone, and now it's actually going to just keep carrying on. So I won't bore everyone with that one because here's what it is. And that's it, we're done. So that was my proof of concept for checking that DNS, checking that Terraform would be useful for actually managing certificates. And I'm happy to say that it was pretty much the same implementation in our actual infrastructure, nearly a lift and shift. So we all know, I guess, as infrastructure engineers, that doing a proof of concept is never quite translates straight into production quality, right? There's so many other things that you got to consider. And that was the same, that's what I found with this as well. So it wasn't as simple as that. I am sort of conveniently not mentioning a lot of things, and here's sort of like a brief list of the stuff I didn't cover. So actually, we didn't have a good look at actually how good production quality HCL is written. So it is pretty much like a template with variable files that you, or environment variables that you can use. So there is a little bit of magic and best practices that you want to follow when using HCL. Now, Terraform modules is another interesting one. So now that I've created this thing, I can now distribute that out so other people can reuse it in a much more user-friendly fashion. So they just might have to specify, hey, what do I want my website to be called? What's the bucket going to be called? Or maybe 3 or 4 things, and it'll just do it for them. So packaging things up and reusing them, didn't mention that. Terraform also has like a Terraform registry, I think it's called, which is like similar to the Docker Hub, where people have already written these modules for you, and you can just say, oh, I want a static website on S3. I'm just going to grab it. So I didn't actually technically have to do this, right? If I really wanted to just make a website. Now, if you go back to the diagram here, like I said, I only wanted to terraform that bit. I didn't even really want to terraform the CloudFront really. So another aspect that I didn't touch on is actually working with existing infrastructure as well. Terraform plays nicely with existing infrastructure, but again, it's just something that you need to consider, and you can import stuff in if you want. Again, talking about our structuring of things, the directory structuring is very important too. Again, in my example, I was just using a single domain with a single website. If you're managing multiple ones of that, you don't want to have a giant HCL file that potentially would break all your domains, right? You want to split them up so that you limit the blast radius if something does go wrong or you make a breaking change somewhere. And that sort of leads on to, I guess, state management as well. So you want to separate the state out. And you'd notice that when I showed you the files that were in my directory, the state of their website, or I guess what the picture that Terraform thinks the infrastructure is in, that was just local. But in an organization, you don't want to be passing state files around either. So you need a way of distributing that. Remote state management is another big aspect that I had to deal with to get this into production. So you can have the state files live in S3, and anyone who's using your repo, they've got to refer to the S3 bucket to get the state. And there's lock tables and stuff as well, so you don't have 2 people clashing when they're making changes at the same time. And talking about state, that sort of also leads on to workspaces. So you can actually use the same code, but apply it to, I guess, different environments. So you can have dev, staging, production, all that sort of stuff, which is really handy. So you can make a change, deploy it in a similar fashion as we just saw, see if it was good, and then if you're happy with it, just change the workspace over to staging, then production, and just move it upwards. So yeah, didn't touch on those things, but again, if anyone wants to find out more or wants me to talk about those things at a later meetup, more than happy to. And that was it. Except for, you still had to use the command line. And we don't want to be doing that when managing a lot of infrastructure. So I did promise I was going to talk a little bit about CI as well. So not only did we get Terraform to manage our certificates and the renewal and the validation, we also wanted to automate that as well using CI/CD. Now, I'm not going to touch too heavily on this either, just a little bit of maybe a teaser if anything. So at 9, we use Concourse CI. It's open source, it's an open source CI tool. And the way that they describe it in the official documentation is it's a thing doer. So it doesn't necessarily just have to do builds and deploys. You can get it to do whatever you want. And this is what I utilize to automate this Terraform. And now this isn't the actual pipeline. This is just one I grabbed off the internet, but just to give you a bit of an idea of what the GUI looks like, it's actually quite pretty. A lot of aviation terms in it as well, which is a bit of a running joke with it. Concourse is quite nice because everything is ephemeral. Every task in every job, in every pipeline is all run in its own Docker container, in its own container. So every task has its own image defined. It gets blown away as soon as the task is finished, essentially. So yeah, it was very nice. So we created the pipeline for this process, and we got a lot of benefits out of doing that as well. So in my repo, which was the Terraform ACM certificate repo, if anyone actually makes a pull request or a merge request into that repo, the pipeline will actually automatically validate the Terraform HCL code, and it will lint it as well. So you can make sure you're not going to merge in any like ugly, unformatted code. And it'll actually fail the job if the linting doesn't pass. It also does a Terraform plan and actually spits it back out into the pull request comments so that you can actually see, okay, if this person's going to make this change, how's that going to affect the infrastructure? Is it going to do what we think it's going to do? When all the reviewers are happy with that, on the actual merge, again, it'll do a Terraform plan, it'll output the plan file and then pass it on to the apply and do the apply automatically as well. And the great thing about that is not only is it very managed and it's in an automated fashion, it's also very scalable. So if anyone wants to add any more domains to the ACM management, they can do so. And it's all run in parallel, so it's nice and fast, separating that blast radius and keeping things separate as well. And that's me. So that's my contact details again. Like I said, hit me up on Slack or email or whatever. And happy to answer any questions anyone has.